Hi, I'm Eyal. I'm product manager for speech to text at the BBC, and I'm actually going to give two talks one after the next. The first one will be about building a platform speech to text service. So both of these presentations are going to be at a slightly higher level, and try and talk you through some of the bigger issues that we encounter when we come to productize speech to text at scale. The second one will be about using speech to text in access services. So why build a speech to text service? Well, the use cases are many. We want to do it for metadata generation. We have a lot of content with varying degrees of metadata. For access services, to create subtitles, voice UIs, recommendation engines that might use the text inside assets. For segmenting longer pieces of content to understand what's in them. So for example, something like the Today program, which is a 3-hour single file. Segmentation will allow us to break it down into clips so we understand what's in the program. Archive search and production tools, so for example, editing by text. Why do we want to do this as a platform service? The main reason is scale. We need to offer speech to text at a scale that is quite mind-blowing. We have more than 1 million hours currently that we want to run speech to text on, and that's before we start thinking about the channels that we have and all the audio streams that we produce on a daily basis. Ideally, we would do speech to text for all of those. We need to centralize our benchmarking and testing effort. There's loads of engines out there. It's shifting sounds. They specialize in different areas. They leapfrog one another. We really need to keep on top of it, and there's no point doing it in different places. We also want to have purchasing power over providers by centralizing our offering. We want to provide a single gateway for speech to text for the rest of the business, so they don't have to worry about the back end. We also want to expose to them a single transcription format. At the moment, each speech to text provider outputs their own transcript format, which makes it very difficult for clients to swap between providers. We also have a bunch of very BBC-specific requirements, such as security. Some of the content might be sensitive. We might not want to send it to a cloud provider, for example. We already have quite a lot of architecture that we could utilize. For example, our own BBC R&D trained speech-to-text engine and physical architecture. And we want to have control over the machine learning algorithms, which is quite difficult to do with external providers. So new words come in all the time. There might be specific vocabularies that we might want to create. And we want to future-proof our service. So we want to present a speech-to-text service to the business without the client worrying about different providers coming onto the market. So this is a conceptual architecture of what we want to do. We want to have a series of speech-to-text providers. Some of them might be in the cloud, some of them might be on premises. We want to have APIs that allow access to individual users or applications or streams. And we want to provide the transcript after we convert it into a unified format. So this is all early days. We're just about starting to build this service. And what have we learned so far? Well, quite a lot already. We learned that there are complex trade-offs trade-offs between the accuracy of the transcript, the cost of the service, and the speed. So it's quite intricate interrelationship between these three factors. We learned that it's very difficult to estimate in advance the processing time of speech-to-text, which creates a problem in broadcasting workflows. When a journalist wants to transcribe a file, it's really important for them to know how long they will need to wait. But this is actually quite a tricky thing to do with speech-to-text engines. We learned that there is a huge variation in accuracy, and there are many factors that determine the accuracy of speech-to-text. So noise, accents, the quality of the recording itself, all of those make the quality very variable, which means we have to do quite a lot of expectation management with clients. As I mentioned, just trying to figure out which speech-to-text provider to use is very complicated and time-consuming. Creating the training materials and the ground truth materials and the benchmarking processes is very complicated. We learned that we have to negotiate multiple output formats and features. So for example, some providers support transcription of audio channels and some don't, which means you have to think about what kind of data you pass into the engine before you hook it up. We learned that speech-to-text gets very expensive very quickly. Not just the speech-to-text service itself, but also the compute that requires to run it. So even if we run our own model and our own speech-to-text engine, the compute power required for machine learning is quite significant. And we learned that the number of use cases is quite large, and each one of them requires something slightly different. So some use cases require accuracy, but they don't care so much about speed. Others require, others don't care about accuracy but want it quickly, and there's loads of other combinations. But we also learned that there's huge demand for speech-to-text from multiple areas of the business, as you all probably know already. So what questions do we still have? Quite a few. One of the big ones is about training machine learning models. Who does it? Who gets to train the model? Should it be the end user, or should we control that process? So for example, a word like Brexit, it's obvious that it should enter the dictionary straight away. But a place name that crops up in the news and then disappears after a week, should we add it to the model or not? Lots of questions around that. Should we include words or also acoustic samples to understand how they're pronounced? That's another question. These are all open questions. We also don't know yet, and I think very few people know for sure, if any. We don't know if there is benefits to having very specialized models. Does it make sense to have a Welsh accent model and a Scottish accent model, or does it make more sense to train a single model on both those accents? These are things that we have no clear answers for yet. We also don't know if there are any gains to be made from combining the results from different providers. Will we get better accuracy from this? As I mentioned, how to assess and monitor improvements across providers in the marketplace. It's a difficult one. Another interesting one that gets quite philosophical quite quickly is, can we trust the machine-generated confidence scores? If the machine tells us it's only half sure about a word, how do we know that the machine knows what it knows? How to measure accuracy better? So there is a word error rate that's used across the industry, but it seems to be the common standard for measuring accuracy, but it's not necessarily the best standard. It doesn't take into account, for example, the significance of the word in a sentence. So is there scope to improving how we measure accuracy of speech-to-text engines? And the big question is, where is the sweet spot between all those factors? Where do we stop to invest in this because either the costs or the improvement to the accuracy are becoming smaller and smaller? So those are sort of questions that we have at the moment. And I'll move on to the next presentation. I might need Pietro for this. Yeah. So, one of the use cases we have for automatic speech-to-text is subtitling. So I want to speak a little bit about that because there is a common misconception that transcription pretty much gets you subtitling. So the first thing to note about subtitling is that it's very complicated. We have three major workflows for subtitling at the BBC. One is live subtitles, and they get inserted in different places. Then we have prepared subtitles, and we also have short-form subtitles that BBC or production staff generate themselves. So quite complicated infrastructure there. There's quite a few types of subtitles, and they often get conflated. So we have the standard prepared hard of hearing subtitles, which is what you can see here, and that includes features like color to indicate different speakers in the scene. It includes descriptions of sounds and actions. Good point. So you can see that something like Manchester accent will not be generated by a speech-to-text engine. Then we have prepared narrative subtitles, which just describe the action. They don't relate to any audio at all. And then we have live respoken subtitles, where a subtitler re-speaks the text in the audio, and they do this on software that's trained on their voice. And the other thing that live subtitlers do is they get feeds of text from the newsroom, for example, that they can just cue live. So they don't have to re-speak everything. So I mentioned transcription is not the same as subtitles. So the subtitles that we produce have quite a lot more than transcription and require quite a lot of work on the transcription. So for prepared subtitles, the BBC is committed to 100% accuracy. Subtitles also add speaker identification using color, and that gets actually quite complicated when you have more than 4 speakers in a scene, for example, because there are only 4 speakers, 4 colors that we use for accessibility reasons. There's sounds that you need to describe, or any kind of action that a person with hearing difficulties will not get from the dialogue. There's also positioning of the subtitles to avoid important areas of text. So, for example, in game shows, the subtitles often have to be moved to the top of the screen. We also think about line breaks, so they reflect natural speech. That's really important for readability of subtitles. Often, transcript is also edited to allow more time to read. If somebody speaks very, very quickly with a few words repeating, the subtitler would remove some of those words to allow the reader more time to read the subtitle. And they also add punctuation, which is very important for readability. And finally, prepared subtitles also take into account shot changes. So the subtitle will appear and disappear on a cut. So there's a real craft to creating subtitles where transcription is just the starting point. There's quite a lot that needs to be done on the raw transcript. So for non-professionals, there is a lot of value in automatically generated transcript as a starting point towards creating subtitles. It's also very handy if you have a transcript from the production. It's very handy to have a speech-to-text engine align the transcript with the audio so you can then chunk it into subtitles. We've also found that for short clips, speech-to-text is not worth the effort usually. So for a producer in the newsroom, if they need to subtitle a 3-minute clip, they will just type in the transcription. It's not worth uploading the file, waiting, and downloading the text. Often they also add the narrative captions that just describe the action. And this is something that needs to be worked into workflows involving automatic speech-to-text, because those narrative captions have to also be created in the same UI, preferably, and not clash with the subtitle. We also know that for professional typists or subtitlers, a transcription that's less than 80% accurate has no benefit. It takes them more time to create the transcript than to type in the text themselves from scratch. And we also know that professional live re-speakers achieve up to 98% accuracy with speech-to-text engine, but there's a big caveat here, which is they use a speech-to-text engine that's trained on the voice, and it takes them something like 3 months to train a re-speaker and the voice recognition system. They use specialized software, they use their own preset vocabulary, and they use verbal shortcuts. So they can say something like XYZ, and that will automatically translate into a longer phrase. And they also use prepared text feeds, as I mentioned, from the newsroom or places like that. And the other thing to take into account is that professional live re-speakers they do an amazing job, and their powers of concentration are phenomenal, but they can't do it for more than 20 minutes at a time. So we would usually have 2 on every shift rotating. So these are quite a few caveats around the use of speech-to-text in live subtitle production and in prepared production as well. And again, here we see a trade-off between latency and accuracy. So speech-to-text engines that produce live captions, the more latency you allow them, the better the accuracy. But that creates a very bad experience for the user when the subtitles are more than 2 seconds behind the visuals. That's it for me. Thank you.
Are there any questions?
Thank you. My mind is blown that there is such a role of re-speaker. That's so cool. And I was wondering, is that the voice that is then re-spoken, is that purely and only used to recognize and generate text, or is that voice also then used for some kind of dubbing, or does it have other uses?
We only use it for live subtitles. So the re-speaker would watch typically a news channel, and they would re-speak what they hear, and what they do is just extraordinary. So they re-speak what they hear, they monitor the software so that it really recognizes correctly, they correct mistakes live, And then they also control the colors and the positioning. And they do all of this live. So it's no wonder they can only do this for 20 minutes at a time. But if you see one in action, it's absolutely amazing. It's superhuman.
A video?
Hmm?
Have you got a video?
I have one, but I don't think it will give you a sense of what they do. I can share a link to a video that we made about access services at the BBC. There's this very short snippet of that in there.
Cool, thanks. So is there another?
Hi, thanks very much. You mentioned it was difficult to determine the processing requirements at runtime. I was wondering why that was.
Because it depends on a lot more than the duration of the file. So some engines will keep trying a few times if they can't figure out a piece of audio. There's just many factors at play. And another issue is that when transcription jobs are not, they have varying lengths and varying bit rates, and some of them are multi-channels, and so it's very difficult to determine in advance how long an engine will take. There's also a curve. So if you have one instance running, it will take the instance, say, there's a sort of penalty when the instance starts up. So you would have 2 minutes just to start it up, and then a 2-minute clip might take up to 5 minutes, but an hour will take 40 minutes. And then it depends how many instances you scale up and how many cores they use and the CPU power, and there are a lot of factors at play.
Cool, thanks.